Hey guys, welcome to another A-level further maths revision video. Today we're taking a look at a core pure topic, which is the mean value theorem. So from chapter 3, pretty brief, but it's definitely worth its own little video just to go through the method. So let's take a look at the first question here from exercise 3b, question 8. So we've got this function here, f of x. So let's just write this down. So f of x is x times x squared minus 4, all to the power of 4. That's a 4, believe it or not. I don't know why I did that. So we want to show that the mean value of f of x over the interval 0 to 2 is 256 over 5. So quite a nice opening question, because we know what we should be aiming for, so we know if we've done it right or wrong, basically. So the first thing I'd always do with a mean value question is just perform the integral of f of x, because don't forget your mean value theorem is just 1 over b minus a of the integral from a to b of f of x dx. So we just work out the integral of f of x first, and then we can just apply 1 over b minus a in between those limits. So looking at this integral here, if you haven't spotted it straight away, probably the nicest way of doing this is using substitution. So the integral of x times x squared minus 4 to the power of 4 dx. So I'm going to use a substitution here. My substitution will just be this x squared minus 4. So u is equal to x squared minus 4. But remember, because we're transforming this from x to u, we need to change our variable that we're integrating with respect to. So to do that, we need to work out what dx is. So if you differentiate this here, du, that would be 2x dx. So therefore dx is just this side here divided by 2x. So it's du divided by 2x. Like so. So at this stage here now, all we need to do is start substituting in. So what would that give us? So x times u to the 4, because this is u, dx, where dx is du over 2x. So I'm going to pull this out as 1 over 2x du. Like so. Just the same thing here, these are just equivalent. So now we've got our new variable that we're integrating with respect to. So now I can cancel this x with this x here, and I can pull out this 1 over 2 here using linearity. This is just a constant. So what I've got now is 1 over 2 times the integral of u to the 4 du. Okay. Now to integrate this, we just add 1 to the power, divide by the new power, just like we would, and then we can substitute u back in. So this would be a half, so this would be u to the 5 divided by 5. So how can I write this better? So in fact what I'll write as is 1 over, so this is u to the 5 divided by 5, so 1 over 2 times 1 over 5 is 1 over 10. So what I get here is 1 over 10 times u to the 5, and we've got our plus c here. Okay, our constant of integration. So what's this going to give us? So that's going to give us u to the 5 over 10 plus c. And now using the fact that u is equal to x squared minus 4, we can write this as x squared minus 4 to the power of 5 divided by 10 plus our constant of integration there, plus c. But we're not done just yet, because up to now we've only just worked out the integral of f of x, but this is most of the work. Once you've done this, you're pretty much on your way. So now all we need to do is apply this here. So 1 over b minus a. So for our question, we're doing this over the interval 0 to 2. So if I just clear all this just so we've got more room. So it's over the interval 0 to 2. So them are our limits of integration. So what's this going to look like? So 1 over b minus a, so 1 over 2 minus 0 times the integral from a to b, so from 0 to 2, of f of x dx. So of f of x, which is x squared minus 4 to the 4 dx. But we've already just worked this out. That's what we've just worked out at the very beginning. We just didn't do it with the limits and this 1 over 2 at the, at the front of the integral. So what we're at, working out here is 1 over 2 times, what we had is u to the 5 divided by 10. So that's x squared minus 4 to the power of 5 divided by 10 between 2 and 0. So if you sub your limits in here, so if you put 2 in, that's 2 squared, which is 4 minus 4, so this is 0. So when it's 2, when x is 2, this just comes out as 0. And then you're going to minus, so it'd be, 0 minus 4 to the power of 5 divided by 10. So just putting all this in, what you're going to get here is 0 minus, so this is, because this is minus 4 to the power of an odd number, this will be minus 1024 divided by 10. And then we need to times this by this half at the beginning. Okay, so this comes out as 1024 over 10 times the half here. So if you work this out, you get 256 over 5. Okay, so that's exactly what we needed there, so that's as required. So not too bad to start off with. And then part B, it's a little follow-up. So we're going to use the answer to part A to find the mean value over the same interval of minus 2f of x. So 2 marks, shouldn't expect too much, we should have enough room down here. So this is minus 2 lots of f of x. So this is just kind of one of these results that you just need to learn. So if minus f of x has the mean value, so it has mean value minus f bar over the interval AB, then that's how we do it for our question. So because ours is minus 2, we're going to times the mean value by minus 2. Okay, if it was minus 4 f of x, we times our mean value by minus 4, for example. So doing that now for our question here, we've got 256 over 5 times minus 2. And if you do this, what you should get is minus 512 over 5. Okay, so that brings us to the end of that question. Hopefully not too bad. The next question here from review exercise 1, a pretty standard kind of example here, where we're looking to find the exact mean value of f of x equals x cos 2x over this interval. So we're using trig functions here, and this is a nice example because it requires integration by parts. So integration by parts is something you should be very confident with at this point in A-level further maths. So f of x is x cos 2x over 0 and pi over 2. So to find this integral here, requires integration by parts. I can't speak. Requires integration by parts. There we go. Okay, so what we're going to be doing here is writing down our v and then writing down our u prime. So v in this case will just take us x, so that's the x here. U prime will take us the cos 2x. So in other words, you differentiate this to get v prime, so differential of x is just 1, and you'd integrate this u prime to get u. Okay, so this would just simply be sine 2x divided by 2, because we've got the 2x here. So now we've just got to apply the formula for integration by parts. So this is uv, so u times v, so this is x sine 2x over 2 minus the integral now of v prime u. Okay, so this is 1 times sine 2x over 2, so just sine 2x over 2 dx. And at this stage here now, work out the integration of this. You can pull out this division of 2 here to the front if you find that easier. So if I demonstrate that. Not quite sure why I'm writing on such a slant. So minus a half of this integral here, sine 2x. Okay, so this integral here of sine 2x, that's just simply going to be minus cos 2x divided by 2. So minus a half here, minus cos 2x divided by 2. And then obviously you just do minus half times this here, so you get cos 2x over 4. So now we can apply the mean value theorem here. So we do it up here now, using all the previous information that we've got here. So it's going to be 1 over b minus a. So the b here is the upper limit, pi over 2. So it's 1 over pi over 2 minus 0 times by the integral of f of x dx. So we've just worked that out here. So if I write it out in full, the upper limit is pi over 2, 0, f of x d of x. So doing that now, 1 over pi over 2 minus 0, so that's just going to be 1 over pi over 2. So you can take the 2 on top, so it's 2 over pi, like so. And then this integral here, we've already worked that out, that's just what we've got here, and we're doing it between these two limits. So nice and easy now. Over 2 plus cos 2x over 4. And at this stage here, just sub your limits in and work all this out. So this shouldn't be too bad. So what you're going to get here, if you do all this, I'll leave that for you because it shouldn't be too bad. So you get 2 over pi. Plugging in your limits here, what you'll get is minus a quarter, minus a quarter. What you get is 2 over pi times minus a half. So the 2's are going to cancel here, and all you get left with is minus 1 over pi. Okay, so that's our exact value there. So again, pretty standard example, but integration is the key concept, so you need to be confident with your integration. So the next question here, another kind of similar example. This time, we've got the ln function here, the natural logarithm, and we want to work out what the value of k is. So we're told what the actual mean value of f of x is over a given interval. We just need to find k. So, like we always do, we need to work out the integral of f of x dx. So the integral here of ln kx dx. So again, you should be very, very confident integrating this. If you're not, you need to just revise it from your A-level maths. To do this integration, you just need integration by parts. So what this is going to be, it's going to be x ln k of x minus x. In fact, it'll be the minus the integral here. I'll write it out in full, minus x 1 over x dx. And if you work this out here, they're just going to cancel to give you minus the integral of 1, which is just minus x when you do the integration. It's minus x. And we have our plus c here, our constant of integration. Now, we're not actually bothered about the constant of integration when we're working out the mean value. So, but we just put it in for here. But for the mean value then, what would that be? So, it's between 0 and 2. So, we're working out the integral here. 1 over b minus a, where b is 2, a is 0. So that's 1 over 2 minus 0, so 1 over 2. Times the integral here of f of x dx. We've already worked this out here. That's what we've got. So all we need to do now is just consider this for 1 over 2 for this here with these limits. Between 2 and 0. Okay. So what would this give us? Plug in 2 here. So that's going to be 2 ln 2k minus 2. Obviously, when you plug 0 in here, it's going to be 0 times ln minus 0, so it'll all just come to 0. So we only need to consider the limit of 2. So that's a half 2 ln 2k minus 2. And the thing we've just got to add on here is that we know this given mean value is equal to minus 2. So I can set this equal to minus 2 now, because we're going to need to do that to solve for k. So here now, we've got half of this expression here. So just timesing each thing by a half, that's going to be just ln 2k minus 1. So we take this all the way to the top. So that's ln 2k minus 1 is equal here to minus 2. Like so. So now add 1 to both sides. So you get ln 2k is equal to minus 1. And now we need to anti-log here. So this is going to be e to the ln 2k. So you just get 2k is equal to e to the minus 1. Like so. And then just divide through by 2. So k is equal to e to the minus 1 divided by 2. Which you could also just write, if you really want, as k equals 1 over 2e. And there we have it. So 4 marks for that. Again, another pretty standard example. So just make sure you can do these basic examples. You shouldn't find anything really too challenging from the rest of it. And now we move on to the last question. This last question is not classed as an examination question, but I think it's a good question to consider, considering the key concepts of integration for this one. So the question asks you to use geometric reasoning to explain why the mean value of f of x equals sine to the power of 5x on the interval 0 to 2 pi, why is it 0? So if we're using geometric reasoning, a good concept here is to get a graph. So I've used Desmos for this. You can try and draw it by hand if you want. Desmos is a really nice tool for doing this. So this is my graph here now. So let's just write this down. So if I change it to black ink, so this is the graph of f of x is sine to the 5x. Okay. Now obviously I've kind of restricted it from here. This graph is periodic, but we need to just consider a few facts. So we're looking from between 0 to 2 pi, so from 0, which is here, to 2 pi here. Okay, so that's 2 pi there. So we're asked to explain basically why is the mean value equal to 0. Well, let's just consider all our points. So this is pi over 2, 1. That would be pi 0. This will be 3 pi over 2. And then minus 1. And this is 2 pi 0. Okay? So, essentially, the key idea here is to look at the facts of what's happening with the areas. Remember, integration is looking at areas underneath a curve. So, what we're essentially looking at here is this area and this area here. Okay, so why is this important? Well, you could technically split this integral up, because what we're looking at here is why does this area essentially cancel with this one? Well, let's consider this by splitting the integral up. So, split the integral up. Because you can, this is the key concept with integration. I'm going to integrate now between 0 and pi, so from 0 to pi, and then from pi to 2 pi. So splitting this up now, so this is the integral from 0 to pi plus the integral from pi to 2 pi. So the key idea is that these two integrals here, these integrals on the right hand side, cancel. Okay, so essentially the integral of f of x dx in this case is equal to 0, and if the integral of f of x dx is equal to 0, then no matter what we're trying to do with the mean value, it will always be equal to 0. So this implies the mean value is also 0. Okay, so it's classed as not being examinable, but it's, you know, I think it's a good question to consider and just to dwell on. So that brings us to the end of this video. Hopefully not too long. I hope it's helped. Any issues, any problems, any mistakes, please just let me know down below.